So first of all, yeah, it does make the functional value negative, okay? And of course, it also make it half, you know, half than half of the previous one, half of what we had. We had f of x, now it will be half of that, and also it will be negative. Can you see that? And of course, it's the functional value. It depends on the functional value, right? So that means if we had f of x, from this we are going to negative half f of x. We'll get half of that, and obviously we'll have something negative. So clearly this negative 5 will now become negative half times negative 5. So it will be a positive 5 halves. Can you see that? So clearly 3,5 halves should be on the graph. Okay, that's the algebraic sense, because if you're multiplying the functional value by half, it's actually cutting it into half, right? Whatever you had initially, which is this, now in return you'll get half of that, and obviously in addition to that, it will be negative. Okay, obviously, as I said, it's the functional value, which is y. Y is obviously the functional value. We are cutting it half into half, and obviously it will be a negative. So only y changes to from positive 5, or rather negative 5 to positive 5 halves. Okay, does it make sense now? That's the algebraic sense, of course. Okay. All right. Next, what's next on your? Okay, so we don't do number 8 on chapter 2, right? Okay. Chapter 2, number 8. No, you don't need to do chapter 2, number 8. Yeah, that's right. Exactly. What's next? Anything you have in your list? Obviously, if you have started solving problems, you might get 1 or 2 problems which you want me to solve. Again, 12, you don't need to solve it. We haven't covered this type of problems for you, right? Oops. Okay, why would g of x equals negative 6x squared plus 2 even and not odd? Okay, which problem is that? I think it's number 9, right? Oh, okay, so the thing is, you need to replace your x by negative x, right? So let me show you how can you do that real quick. So g of x, so clearly you can see it's actually the same as g of x. And if that's the case, we say that the function is even, right? Okay, next. Anything else? Again, if you haven't started reviewing stuffs, you should do that as soon as possible, because it's a comprehensive final and it does require you to practice uh, at least a handful of problems, and it will definitely take some time to cover, to review all the stuffs once you start. So I think you should start as soon as possible. Okay. All right. Next, 21. 21. Okay. So for the given function f and g, complete parts A to H for A to D, also find the domain. Okay. Okay, so the first one is, it's number, oops, sorry. I think it's number 9. It's number 21. F of x is, what is that? Okay, square root of 3x, and g of x is 5x minus 8. 5x minus 8, right? Yeah, okay. Okay, so first of all, you need to find this, f plus g of x. Okay, so the property for this is you can actually add those separately. Okay, this is actually the same thing. So if we do that, it will be square root of 3x plus 5x minus 8. Okay, so that's f plus g of x. And now you need to find the domain of as well. Now, what should be the domain of this? Take a close look at this. Don't look at the answer. Try to see what's the reason behind this. If you just look at the answer before trying, I think your preparation could be, I guess, what should I say? The right choice of word would be, your preparation could be um, hampered, I should say, because it shouldn't be as good as it would have been if you had tried it first and then look at the answer. Okay, so the good idea would be try it first and then check your work looking at the answer. Anyway, so by just eyeballing, can you see what should be the domain? Excuse me. And whatever your answer is, of course, can you tell me the reason behind that? You don't need to write the reason in your test, but obviously you need to know that, right? What should be the domain? Anyone? Just give it a try. Okay, John, why do you think it should be greater or equal to 0? What's your logic behind this? Very good. So this is a polynomial, right? No worries about that. Any real number is okay in that portion. But for the square root part, whatever you have inside the square root, that means this guy has to be greater or equal to 0, right? So if you solve it for x, we get x greater or equal 0. And that is indeed your answer. Okay, so your domain should be x greater or equal 0, or you can write like this. Okay, oops, sorry, like this, depending on the question. If your question wants you to write like this, that means using the interval sign, you have to write like this. Otherwise, I think you can write like this. However, your question wants you to do. Okay, so next, it says f minus g Again, the idea is the same. F minus g will just change signs here. That's it. And obviously the domain will still be the same, okay? Because square root of 3x minus 5x plus 8 is still the same case. For this one, all real numbers will be your domain. And for this one, x greater or equal 0 will be your domain, okay? So that should be your f minus g of x. For a to d, it's actually the same. Let me see if I have anything else for e to e, f, g, and h. Okay, so all of these are easy. Okay, any other question? So the idea is same. And as you can see, it has several parts, right? A to h. So 7 parts in total. You will actually see questions like this, where you will have 6 or 7 parts, and you need to answer it one by one. Okay. Okay, what's next? It doesn't need to be from the review sheet. If you have started practicing from the book, um, and you are struggling on that, you are struggling with that problem, again, it's the same idea. I don't see any point doing the same thing over and over again, because if you have understood what I have done here, the rest is exactly the same thing. Nothing changes. So what I'll do, if I have enough time before we finish today, I'll come back to it, okay? But let me first try and solve as much problem as possible, okay? And obviously, using this idea of A and B, I have shown A and B here. Try to solve other problems first and check your work. That will be really helpful for your preparation, okay? All right, next is 23. Is it 23 from chapter 2? Okay. Use a graphing utility to graph this is this on this interval and approximating local maxima and local minima. Okay. Okay, so you don't need to do that, because as you can see, it says using graphing utility. So you don't need to do that, because that actually doesn't require you to do any maths. You can just look at the graph and answer those questions. So I've avoided giving you questions like this, okay? Okay, so chapter 5, question on. Okay, just give me a second before I load that, okay? Just give me a second. Chapter 5, okay. Where is chapter 5? Sorry. Oh yeah, got it. Okay. You need to write the question for me, okay? Because I don't have the, I can't really open the copy of the book right now. So because I don't have the hard copy, I can only see that if I start or rather stop sharing the screen. That's not feasible, I think. Anyway, so chapter 5, question 1, the data in the table below represent the country's advertising revenues for the years 2005 to 16. Complete the parts A through D. Yeah, you don't need to do problems like this. That's something outside what we have covered. Daniel, meanwhile, if you could write the question for me, or you can take a picture and send it in this chat section. You can do that. As you can see, you can add or rather send files from the chat, okay? Okay, all right. Then can we do C and D on question 2? Question 2. Okay, so it's chapter 5, question 2, C. Okay, so f of x is x squared plus 4 g of x equals to square root of x minus 2. Okay, and C says f of f, that means f is composed with f. So this means we are actually looking for this. So we'll replace our x, by f of x, okay? Wherever we have x, we need to replace that x by f of x, okay? So let's try and do that. So in place of x squared, we will actually now use x minus, oh, sorry, my bad. Instead, you will use x squared plus 4. In place of your x, you need to use that. Now you need to square that because of this, because you are replacing this x by x squared plus 4, right? Okay. And obviously, you need to add 4 here as well. So all you are doing here is you are replacing your x by this guy, the entire thing, okay? And where is that? Sorry. Okay. And now you need to simplify it. So that's problem C, right? Where is that? Okay, so ABC. Okay, so let's solve this, because I was wondering if you can keep it like this, but looks like they want you to simplify. Yeah, I think that's a good idea. It's always better to simplify. So if I can expand this using the a plus b, the quantity squared, so it will be x squared plus 2x y plus y squared. That's only for this expansion plus 4. So x to the 4th plus 8x squared plus 16 plus 4. So x to the 4th plus 8x squared plus 20. Okay, let me check the answer. X to the 4, 8x squared plus 20. Yeah, that's it. So that's the answer. Okay, because you are asked or you are required to simplify. All right. Again, the idea of this type of problem is you will replace your x by f of x or g of x, whatever given in your problem. So wherever you see this x, you need to replace that thing by the new function, and obviously then take care of the squares and the other terms. Well, that's the expansion, a squared plus 2ab plus b squared. That's a plus b, the quantity squared. That's the expansion, right? Because on this occasion, your a is x squared and b is 4. So 2ab, okay? All right. Okay, so Daniel, you have x to the 5th, okay? For this type of problems, obviously you need to go for the factorization, right? You need to look for the multiples, or rather factors, my bad, oh, sorry, factors of your constant term, which is -4 as far as I can see. You need to look for the factors of those, and you need to check if you plug in any of those, if you get 0 or not, okay? If you get 0 for any of those, then x minus that is a factor for you, and obviously that will be a real 0 as well. But you need to go for the factorization. For the test, you are not required to do problems of this big, degrees of 5, 4, or something like that. But yeah, uh, uh, it's a good practice. You can practice all of those. Just look for the factors of 4, which gives you 0 for the function. Okay, and then you need to factorize it. Okay, try that and let me know. It's not required for the test, that's why I'm not really showing it. But again, if you're interested to do that, try that after you finish, and I'll help you with that, okay? It's not a big problem. Only the coefficients are big, that's the problem. Otherwise, you can sort it out. All right, what's next? Should we do question 3? Haven't seen that format. Okay, let me see. Question 3. No, you don't need to do that. That's actually a hard one. You have actually seen how to solve problems like this, but as I said, I want you to know the formula and the transformations and the methods. You can use the same thing here, but it will still be harder for you. Okay, if you want, I can solve it for you, but again, you don't need to solve problems like this. This is a harder one than you have seen. Okay, problem 5. Yeah, problem 5 is something you can do, because you have, as I said, this doesn't require you to do too many things. You have seen problems like this. Do you want me to solve that? Well, again, my first suggestion is don't really go for problems which looks complicated before you give it a try. You should try it first, and then if you can't do it, then we should discuss that. Otherwise, if I just show it to you, uh, it doesn't really work well towards your preparation. Anyway, I'm going to solve it. But that's my suggestion. To get a better preparation, you should try first. Okay. All right. So what's the condition? What's the main thing for solving problems like this? What do you want? Needs the same base. Very good. So it's already 9. You can't really convert this to 81. You can, but it will be complicated. But you can definitely convert this to 9, right? So it will be 9 squared, 2x. So that means if I simplify it, as you can see, it does look complicated, but it's actually easy. Once you start doing this, you can see now we can actually see the base is the same. So we can set the exponents equal to each other. Okay. And now if we solve it, x squared minus 4x minus 21 equals 0, we can factorize it to get our answer. So we need the sum of negative 4 and the product of negative 21. So which two numbers give you the sum of negative 4 and the product of negative 21? If you can figure that out, the problem is done and dusted. Very good, negative 7 and 3. So negative 7 and 3. So it will be x squared, x minus 7 and x plus 3, right? You can straight away take it from here. So your answer would be x equals 7 and negative 3, okay? Because that's your real zeros. This will be 0, from this you'll get a 7. This will be 0, from this you'll get negative 3. So that's your answer, right? As you can see, it's actually easier, okay? Okay, what's next? Question 7, okay. Let me see. So problem 7, okay. Hmm. 2 days. Well, have you seen a problem like problem 7 in our lecture? I don't think so. I don't think we have covered anything like this. So again, let me see. No, I don't think I have showed problems like this. So you need to pick your problems which I have showed or which you have seen during the lecture, okay? You don't need to practice problems other than those, okay? Spend your time wisely because as I said, lots of stuff to review. So just pick your problems, okay? Okay, what's next? Well, as I said, you should only, ask questions or discuss problems which you have already tried. Without giving it a try, you shouldn't see the solution. That's my suggestion. As I said, for a better preparation, you should try first and then discuss and then go for the solution, okay? So I think if you have started working on a particular section, doesn't matter. It doesn't mean that you need to start from the second chapter. You can always start anywhere from anywhere as you want. But it's better to do that sequentially, because in channel the chapters are set up in a way uh, where you can actually use concepts from the previous chapters to solve problems in the current chapter. So if you do it one by one, sequentially, it should help as well. Again, that's my suggestion. You have your own study plan. You don't need to change that for me. You can stick to that, but that's my suggestion. If you want to have a really good preparation, you should practice problems first, and obviously sequentially, and then you should go for the solution. Okay. The reason I have given you the solution is obviously you can, so that you can check your work. Okay. So don't look at the solution in the first place. All right. Any other questions? Otherwise, I can pick a problem and show that. Okay. Well, again, as I said, everything I've covered is equally important. Yeah. So I can't give you any other um, suggestions than those, because I've already cut it short. As you can see, I could have showed more topics from each chapter. I've tried to keep it uh, as less as possible. Obviously, I have to show a couple of things which are really important, but in this small duration, it was difficult to show this, because you need to understand a lot of things in a single lecture. That's what I don't really like. Anyway, that's how it is set up. So let me show one problem from the second chapter, which could be helpful. Okay, let's see. What can we do? Alrighty. So, okay, I think, okay, so this will have, okay, 5, 11, and domain. Okay, let's try this. So let's say I have a rational function, okay? Let's say x over x, uh, x squared over x squared minus x plus 6, okay? Let's try this. Okay, so from this, you need to write this. The first part is you need to write this in the lowest form, okay? You need to write it in the lowest form. That's the first question. So the first part is it written in the lowest form, or can you actually write in a format which could be the lowest form in place of this? Can you change it? So we are looking for the sum of -1 and the product of 6. positive 6, obviously. Can you see anything which will give you a negative sum of -1 and product of positive 6? Anyone? Okay, let me change this. Let's see. Let me give it -6. Now is it possible? Again, it's a practice problem. I'm just trying to see whether you know this stuff or not. First question is it written in the lowest form? Can you find any way to rewrite it? Okay, so Ryan said x minus 3x plus 2. So yeah, so for -1, sum of -1 and product of -6, we actually have -3 and 2. So the lowest form would be x plus 2, x minus 3. Okay, very good. So that's the first part. The second part could be what else? I'm actually making this up for you. You'll see similar questions in the test. Okay, not exactly this way. You could have different parts and different things, but you'll see questions like this. So next part could be, okay, yeah, what could be the domain of it? What's the domain of this? Excuse me. What is the domain? Anyone? Is it from -3 to 2? Because the way you have written, it means from -3 to 2. Only this interval is the domain. Anyone else? It's not the right answer though. Okay, so I have several answers. Let me see. So -infinity to -2, -2 to 3, and 3 to infinity. X not equals to -2 and 3. All real numbers except -2 and 3. Yeah, exactly. So yeah, all of you are right. So this means your denominator can't be 0. So it can't be 0. It can't be 0 either, right? So x can't be -2 or 3. Apart from these two, everything else will be your domain. So depending on the question, it will be either from -2 to negative infinity to -2, -2 to 3, 3 to infinity, or you can write it in this format. Okay, very good. All right, next could be, yeah, the intercepts. How can you calculate the intercepts? This is your function, of course. And you are asked to calculate the intercepts. How can you calculate that? Anyone? Again, spend time on this. No intercepts. Okay, why do you think? Okay, y-intercept is 0. Okay, let me see. So the problem is x squared over x plus 2, x minus 3. Okay, So that's our f of x, right? So the y-intercept would be plugging in 0, right? If we plug in 0, what happens? It will be 0, it will be 2, it will be -3, so 0, yeah. So 0 will be the y-intercept, right? And if we plug in f of x equals 0, that means x squared equals to 0, because the denominator can't be 0, so x equals to 0, yeah. So 0, 0 will be, I mean, you can write like this, that it will have an intercept at x equals 0. That will be your x-intercept, right? Yeah. And at y equals 0, you'll have your y-intercept. Very good. Okay. What could be the next part of it? So that's A, B, that should be C. You can see you will have several parts like this, which will be, you know, small in terms of uh, the type of calculation you need to do. But again, you may need to spend time on that, okay? So read the question carefully. I'm repeating it myself over and over again, and then imply the methods you know, okay? Next. So, okay, so next we might want to know what's the behavior of this. How does it will behave? Okay, how will it behave? That means, will it cross the x-axis? Will it just touch the x-axis but not cross it? You know, how can you find the answer? So the question is, will it cross the x-axis, or will it touch the x-axis? This could be another question. So touches at 0, multiplicity 2. Okay. So how did you calculate that it touches your graph at 0? What's the idea behind this? X equals 0 comes from x squared, and 2 is multiplicity 2, which means it touches. Anyone else? Okay, so what's the idea behind this? That means you need to take the numerator, whatever you have here. Can anyone tell me the idea? Because again, if you don't remember the main idea, how can you actually calculate it? That might be causing problems to you. So the best thing is to refresh your mind, to go back to the content, right? F of x equals 0. So if you plug in f of x equals 0, this is my f of x. So your denominator can't be 0, right? You'll have a vertical asymptote there, okay? So that's the idea. Your denominator can't be 0. You'll have a vertical asymptote there. So all you need to check is the numerator, right? And you can even see that from here. If your functional value is 0, that means a of x will be 0. And you need to solve it for x. So for this problem, we had x squared equals 0, right? If we solve it for x, it will give us x equals 0. And then we'll need to look at the multiplicity, right? And for this one, we have even multiplicity, right? And if you have even multiplicity, your graph will touch the x-axis, then it will again go back to some other, go to some other directions, but it will never cross it. It will not cross it, okay? If we have odd multiplicity, then your graph will cross the x-axis, right? Do you guys agree? Is there anyone who is unfamiliar with this, what should I say, unfamiliar with these properties? Do you agree? First of all, do you agree that this is the case? I'm talking about the generalized things again, because again, if you want to solve a particular problem, you first need to go back to the general idea, okay? Because things could be different depending on the problem you have, okay? All right. Next, the next part could be, yeah, I think next we can go for the vertical asymptote. Now, what's the idea behind calculating the vertical asymptote? Anyone? Just give it a try, even though you're wrong, that's all right. It is the place where you can actually express yourself, okay? Don't bother if you're wrong. We are here to help each other, right? Real zeros of the denominator, yeah, very good. So that means whatever you have in the denominator, I'm talking about the general idea again. So that was D, so it should be E, okay? Is there anyone who has objection with the red color? If you have, you can say that privately if you want, okay? Otherwise, I might carry on doing this. Or I think I can use the white color anyway. So for the vertical asymptote, you need to set your denominator to 0 and solve it for x. That means you need to look for the real zeros for the denominator. So on this occasion, we have, I think it was x plus 2, right? Yeah, x plus 2, x plus 2, and x minus 3. That's the denominator we had. We are setting this to 0. If we solve it for x, we'll get, oops, sorry, we'll get x equals -2 and 3. And if you are clever enough, you can actually see that from the domain. Can you see that? There you go. This guy has no defined functional value at -2 and 3, and you are getting this by setting your denominator to 0. In other words, you are actually calculating the real zero of the denominator, so that is clearly your vertical asymptote. You don't even need to recalculate it. But yeah, again, if you want to be on the safer side, you can recalculate, no problems with that, because as I said, you'll have plenty of time. So don't uh, go for glory, you know. Stick to your plan the way you want to do this, even though that's time consuming, even though that looks stupid, doesn't matter. As long as you can do it right, that's what you want, right? So your vertical asymptote should be at x equals -2 and at x equals 3. Okay. All right. Any question from this? Anyone? Okay, looks like you are okay with this. Next, I think we can go for the horizontal asymptote. Okay, and for that, you don't even need to calculate anything, right? You can just eyeball the problem and you can decide how many, or rather, is there any horizontal asymptote or not, right? So a quick question, is there any horizontal asymptote? Let me go back to the main problem. Here you go. That's the main problem. That will be easier to eyeball, right? Daniel said n equals m, y equals 1. Very good. So let me give you the idea again, right? So let's say m is the denominator, oops, sorry, is the degree for the numerator, okay? Oops, I think I should write like this, yeah. And n is the degree of the denominator, okay? You can just eyeball these two numbers. What I mean by this is these two numbers, m and n, and you can decide whether or not there is a horizontal asymptote, okay? So the idea is, again, if m equals to n, then you need to take the ratio of the leading term, okay? You need to take the ratio of the coefficients of the leading term. What is the leading term? The term with the degree. Your degree for the numerator is m, so the coefficient for that term is a. Same goes for the denominator, it's b. You need to take the ratio of these two coefficients, these two leading coefficients, that's a over b. And y equals that will be your horizontal asymptote. And as you can see, our leading coefficients are 1 and 1. So as Daniel said, y equals 1 is going to be our horizontal asymptote. Can you see that? Let me write it for you. So that would be, let's say, part F, okay? So it would be 1. Y equals 1 could be your horizontal asymptote, okay? Next, a very, very trivial question. Is there any oblique asymptote? If yes, where? If no, then you can just click the option no, there is no oblique asymptote. But if there is, then you need to write, or rather find, where that is. So Daniel said no. Why? Daniel, why do you think there is no oblique asymptote? Just give it a try. Why do you think? Anyone else? Uh, is there anyone who disagrees? Multiplicity, or what do you mean by multiplicity? Do you mean the degree? Okay, so again, the idea is if n is just one more, sorry, I think, yeah, if m is one more than n, that means if the degree of the numerator is just one more than the degree of the denominator, then you'll have an oblique asymptote. On this occasion, n is equal to m. Okay, so that's not the case. So we'll say there will be no oblique asymptote. Does this make sense? What else? I think that's it. Yeah. Yeah. This could be a problem, right? You could have different parts as well. As I said, it may or may not be in this exact form, but again, this could be a problem. As you can see, it has 7 parts, right? It could have 8 parts, like up to H, something like that. But the question would look like this, uh, can you be asked of the range? Yeah, you can be. You can be asked to write the range. So for the range, I'll do either, or rather you might see either of this. You might be asked to find the inverse first. And of course, if you can find the inverse, the domain of the inverse will be the range of the main function, right? That's the idea. Or the other type of question for the range could be from the graph, find the answer, find the range, rather. Okay. All right. Okay, have you found any other question you want me to solve from the review sheet, or any other problem which you think we might do? Like Daniel asked about the range. Are you thinking about any type of problem that could be, I can't say whether it can be asked on, or whether it will be asked or not, but it can be, right? No other questions? Should I do it randomly? You can do another one that might be asked like we just did. Okay, okay, I understand. You're being very clever. Uh, okay, yeah, let me give it a try. Because it's difficult to generate questions quite similar to that. I'm trying to do that. Obviously, I'm trying to avoid the exact same question, but obviously the type can be shown here. So, okay, let me try this one. So let's say I have a problem like this. Let's say g of x. What should you do? Okay, let's try this one. So 3x squared plus x minus 6 or minus 2. Let's try this. So let's say that's a quadratic function, okay, because the degree is 2. So that's the quadratic function. So one part could be, let's say, yeah, I think one part could be find the vertex. Can you do it? What's the formula for the vertex? Anyone? Just give it a try, because you'll obviously review this. Yeah, very good. Negative b over 2a. So let me write it just here so that you can actually compare it, right? So your a is 3 here, and your b is 1, right? So your vertex should be negative b over 2a, which is negative b is negative 1, because b is 1 here, you can see, and a is 3, so 2 times 3, so negative 1/6. Okay, so if the question says, let's say, where is your vertex? Is this the answer? Just imagine this. If the question says, very good, yeah, it's not the answer. Because if the question says, where is the vertex? That means you need an ordered pair. Can you see that? Obviously, the first value will be 4x. Second value will be the functional value of that. Very good, yeah. Yep, obviously. Very good. So in that case, it will be h. So your vertex will actually be h comma f of h, the functional value at that point, right? So that means if the question asks you to point out the vertex, or probably it will say you to write it using an ordered pair, then you need to go for this. Okay, yeah, that's you can write that as well. That's the other format. Either way will do. That's actually the same thing, so no problems. That's actually the same thing, whichever you like, no problems. So we actually need to find this, and if we plug in, let's see what happens. uh, let me do it here. So 3/1/6 squared minus 1/6 minus 2, right? So it will be 3/1/36, 1/6 minus 2. Oops, I think I need to do it here. So 3 and 36, it can go 12 times into that. So it will be 1/12 minus 1/6 minus 2. If I simplify it, 1 minus 2 minus 24, using the concept of the common denominator. You can check this later on if you want. So it will be -26, -25/12. So your vertex will be at -1/6, comma -25/12. Okay. So that's your vertex. Okay. Very careful. Okay. Be very careful. Look at the question first, what it actually wants you to do. Okay. Does it want you to find only the x value using this formula? Does it want you to locate the vertex like this? Or does it have an instruction below the question that write using an ordered pair? You need to take a look at the question, okay? Like the one we have discussed yesterday, remember? It said, don't start rounding before the final stage. So that means if you start rounding right from the word go, you might get penalized. So look at the instruction very carefully. Okay, it's a computerized question. It's a computerized online-based platform. So it's quite, it's actually uh, uh, absolutely, I think it's completely different than an in-person exam, right? Where the instructor could actually give you credits by just recognizing that you actually know the stuffs. Whereas it's difficult to get partial credits. I have allowed partial credits though, but I'm not sure how much will they give you. Although I know that you know the stuffs, probably because of the instruction which you might have missed out, you could lose a lot of points. You know what I mean? All right, so the next part of this question could be what else? So we have the vertex. Oh yeah, of course, axis of symmetry, right? The next question could be axis of symmetry. What's the formula for that? Anyone? Just give it a try again. I know you have seen this way before, so you might not remember the exact formula, but just give it a try. What's the formula for the axis of symmetry? What equals negative b over 2a? You have equals negative b over 2a, but what's on the left hand side? X. So the idea is x equals b over a is your axis of symmetry, right? And on this occasion, it will be negative 1/6. So that should be your axis of symmetry. Do you agree? Okay, next. What else could be, could you do from this? Okay. Yeah, obviously you can go for the intercepts. Yeah, that should be a good idea. So this could be part B, this could be part A. Okay, so part C could be intercepts. Okay, so again, if we plug in 0 in place of x, we should get the intercept, y-intercept precisely. So plugging in 0 in place of this will give us only a -2. Can you see that? Because x will get banished. So we'll have a -2, and this will be your y-intercept, right? And if we plug in 0, what was that again? 3x squared plus x minus 2, okay, plus x minus 2. So if we set this to 0, and if we can solve it for x, we should get the y-intercept. So let's do that. So we are looking for, sorry, we're looking for the product -6 and sum as +1, right? So what could be the numbers, the pair of number, of course, pair of numbers. So we could have +3 and -2, right? Can you see that? No, I don't mean -2. You have a 3 here. You remember from Math 96? If you don't have 1 in front of x, if it was like this, that means if your coefficient, the leading coefficient is 1, then you look at this. But if you have any other coefficient other than 1, you need to take the product of these two, right? So it's -2 times 3. So the product will be -6, not -2. Do you agree? So that means, so it should be 3x squared plus 3x minus 2x minus 2. So we can factor out 3x from this. So 3x would be x plus 1, and we can factor out 2 from this. It should be x plus 1, and now we can factor out x plus 1 from both of these terms. So x plus 1, 3x minus 2 equals 0. Okay, so x should be -1 and 2/3, right? Because if you solve it for x, you'll get a 2/3. Any question from this? Again, it's from Math 95 or Math 96. I think it's from Math 95 anyway. But again, you'll need this concept, right? Otherwise, if you start doing it for -2, you'll actually get a different result. Shouldn't the 2 be negative because 3 minus 2 is +1? 3 times -2 is -6. Yeah, I have taken -2 here. That's the positive 3x, the negative 2x. Oh, I can see, yeah, here, right, yeah. I forgot to add -2 there, but yeah, I have done this right in the main calculation. Yeah, no worries, thank you for the correction. Yeah, so as you can see, your y, this should be x-intercept, right? Yeah, your x-intercepts are -1 and 2/3. All right. Okay. Next, intercepts are there. Okay. What if I say, um, what if I say, um, find the domain and range from this? Can you eyeball it? Let me give you the function. Here you go. Let me erase this for you. Yeah. So that's your function. That's your function. What's the domain and range? Okay, so I can see the domain is negative infinity to infinity. And why is that? Anyone? Why is this uh, domain from negative infinity to infinity? How can you calculate that? So the idea is, if you have a polynomial, right? If you have a polynomial, straight away you can say that, hey, all real numbers, set of all real numbers will be my domain, right? It's a polynomial, so you don't even need to calculate it. All right, let's see what happens for the range. So 6 squared plus x minus 2. How can you calculate the range? I think I've just answered this a couple of minutes back, right? Anyone? Very good. The domain of the inverse. So that means, first of all, we want to calculate the inverse. Okay? So we'll replace x's and y's. Actually, we'll alter the positions for this like this. Okay? And then we'll actually uh, find the answer. So what should we do? Okay, so can't you also just use the vertex of the parabola? Okay, so again, the other idea could be, of course, using the graph. If you can see what's the graph of this, where is that? Sorry, oh, there you go. What's the graph of this? Excuse me. You can always uh, eyeball the range. Yeah, you can do that. Either will do. Either you can go for the inverse and take the domain of that, or you can, what you can do, you can go for the graph. You can visualize, you can imagine how does the graph will look like, and then you can define the range, right? So we have replaced x's and y's, not y's, the solo y. Okay, now what's next? What should we do? Go for the generalized idea again. What's next? Anyone? What should we do? What's the general idea if you're trying to find the inverse? Solve for y. Very good. So that means we want to isolate the terms with y's and we'll change sides for the other. So it will be 3y squared plus y equals x plus 2, right? I've just changed sides for this. So it has become x plus 2. Then I've just flipped sides for each other, okay? So if I solve it for y, what should I do? I should take this, oops. Okay, so 3y squared plus y. Okay. So if I plug in y, it will still have a 3y plus 1. Doesn't really help. We want to isolate it for y, right? So what else should we do? Okay. Anyone? Any guesses? Anything you can imagine here? So x plus 2 and here I have it for y. Okay. So let me see, what can you do? It's a polynomial, right? So, okay, so if I write this as y, okay. Logarithm for the inverse. So taking log won't really help, because if we take log on both sides, 3y squared plus y log x plus 2 doesn't really help us to solve it for y. Okay, let me see whether you can do anything else. So, oops, so first of all, the question could be, does it have an inverse? Is this an one-to-one function? I think we should check that first, right? Yeah, I think we should check this first. Is this, does this have one-on-one correspondence? That's the question. So 3x squared plus x minus 2, right? And with, to check whether it has one-on-one correspondence, we need to check like this. For this, if we get x1 equals x2, then our job is done. Let's do that, okay? So it could be a possibility that it's actually not one-on-one. So then we can't really calculate the inverse, right? So let's see. 3x squared plus x minus 2. Again, that's another concept you have seen, right? So that's the way to check one-on-one correspondence. Excuse me. So 3x2 squared plus x2 minus 2. So 2 and 2 can get cancelled. So 3x1 squared plus x1, 3x2 squared plus x2. Okay, so excuse me. Okay, so if we solve it, first of all, if we take a square root on both sides, on my right, I'll have a plus minus. Can you see that? So to me, looks like it's not one-and-one correspondence. It doesn't have one-and-one correspondence. Because if we take square root to get rid of this, on my right, I'll have a plus minus. For that one-on-one correspondence, that's a contradiction. So it looks to me it's not even one-on-one correspondence. So it doesn't have the inverse. So what we can do, we can go for the graph, okay? So let's quickly do what informations we have. So we have x equals -1/6, which is somewhere here. Let's say that's my -1/6. We have axis of symmetry here, right? So that means graph on the right of this and graph on the left of this will be symmetric, okay? So what's the vertex? Vertex is -1/6, 25/12. So -1/6 is here, and -25/12, that means it's slightly less than 2. So negative, let's say that's my -1, that's my -2. It should be here, okay? How do you know that's concave up? Yeah, that's another thing. That's another concept. Can you calculate or can you eyeball the problem? Where is that? Okay, let me write it for you. 3x minus 2, yeah. If you have a problem like this, how can you decide whether it's concave up or down? Very good. So the idea is, again, let me just give you the general idea again. X squared plus bx plus c, that's your a, right? The leading coefficient. If a is greater than 0, then it's concave up, right? And on this occasion, it's concave up. So clearly, we could conclude that, hey, this graph is definitely concave up. Now, what does it mean when I say concave up? Does it look like this or this? That's another thing. And all of these things you need to remember, right? That's the most difficult thing. You need to remember every concept and you need to synchronize these things, right? Yeah, very good. Yeah. If you have concave up, your graph will look like this, U, right? Very good. So from this, it will go like this. As you can see, the graph has symmetry on both sides of this blue dots. That's your axis of symmetry, right? And obviously it will behave similar on either side, right? Okay, so from this, can we see the, what should we say? Can we eyeball the domain range? Can we? And the answer is, of course, yes. Definitely, what I can see, this graph starts from here, right? Starts from here and it goes up and up. Can you see that? Take a close look at this graph. Just try to imagine what's going on here. Does this graph has, or rather have, any point defined below this point? Can you see that? Can you see anything which is below that point in the y direction? Can you see anything? And the answer is, of course, no. So that means it starts from here and it can continue going up to infinity. So definitely the range will be negative 25 over, oh, sorry, yeah, I think it should be negative 25 over 12 to infinity. Yeah, that should be the right answer. Very good, very good. Can you see that? Because that's the vertex, right? What's the y value of the vertex? I think that's written somewhere here. I'm sorry, I'm scrolling up again to show that. Here you go. That's your y value for the vertex. How did you get negative 1/6? Yeah, negative 1/6 is the x value. Very good. So your y, we're looking for the y value, right? And your y here is negative 25 over 12, right? And it can go up to infinity. So this is not an ordered pair, by the way. This is an interval. Be careful, okay? This is not an ordered pair where your second value is for y, first value is for x. That's a very good point, though. This is basically the interval, right? Do you guys agree? Yeah, right. Very good. So it should be this. Yeah, right. That's quite interesting. So you can see from the graph, you can eyeball the range as well. If it was not a polynomial, especially with even degrees, you could have actually gone the algebraic system as well. But yeah, you can always go for the graphical representation as well. If you can imagine, obviously, but first of all, don't go for the y value of the graph, or rather the vertex straight away. First, imagine how does the graph will look like, because if this graph looks like this, then your answer would be completely different. Okay, so obviously you need to know where is your vertex. Look at the y value of the vertex. That will be really helpful. That's right. But also you need to know whether it's concave up or down. Then if you can imagine that in your head, or if you can actually draw it in a paper and see whether it's going up or down, right? And then you can decide on the range. Yeah, exactly. If it was concave down like this, it would have been negative infinity to negative 25 over 12. Yeah, very good. Yep, that's right. Are you guys with me? This is a really interesting, really basic, and really tricky problem. Can you see that? Again, if you know the stuffs, it should still be easy for you. If you know how does you, what does it mean if it's concave up, or how can we calculate whether it's concave up or down? If you know where is your vertex, if you know what's the formula for calculating vertex, you can easily imagine this even in your head. You don't need to though, you can draw it and you can get the answer pretty quick, right? So that's the beauty of this course, you know. So many small things, still if you can synchronize this, it makes your life a lot easier. And it's really beautiful, isn't it? Okay, so that's it for today.